How to calculate future value in Excel. Let's play around with various future value examples. First, future value scenario. We invest an amount of $1,000 today and want to calculate the future value in year 4 using a 20% expected return or interest rate, whatever your case situation is. There are 3 ways to calculate the future value in Excel. The first way is to construct a formula and calculate the future value year by year. The formula for future value in year 1 is B3 times, open parentheses, 1 plus B4, close parentheses. We lock the column reference by putting a dollar sign in front of B4. The outcome of the calculation is $1,200, $1,000 multiplied by 1.2. We can copy the formula from C3 to D3. $1,200 multiplied by 1.2 equals $1,440. Due to the compounding effect, we get growth on top of growth. The absolute amount of the annual return increases. Copy the formula from D3 to E3 and F3. Here's your answer. $1,000 today at 20% annual compound return grows to $2,074 by year 4. The second way to get to that same future value is by using a formula that skips the intermediate steps and goes straight from start point to end point. F4 equals B3 times, open parentheses, 1 plus B4, close parentheses, to the power 4. That last piece, to the power 4, is written as the little roof sign with a 4 behind it. Let me display that formula for you using formula text. The third way to get to that same number uses the future value function in Excel. Go to the Insert Function dialog box on the Home tab of your Excel sheet, type Future Value, click Go and select FV. As the description suggests, this is normally used to return the future value of an investment based on periodic constant payments and a constant interest rate. But we can also use it for a lump sum situation like we have here. Click OK and you see the function argument showing up. First, we need to specify the rate to be used. Let's have this reference cell B4 rather than typing a number in here. Then we specify the number of periods involved, 4 in our case. We leave the next row empty as there is no recurring payment. In the 4th row, we reference cell B3 for the initial lump sum, the amount that we invest. Then we hit OK and put a minus sign in front of the formula. The reason for this minus sign is that the FV formula assumes we are looking at cash outflows and cash inflows for loan or investments, while we are in this scenario just looking at how the future value of an initial amount of $1,000 grows over time. The cool thing of using cell references in each of the formulas is that we can vary the amount of the initial investment in B3 or the rate of return in B4. And have an automatic calculation of the future values based on the new inputs. As you see in cells F3, F4 and F5, each of the 3 methods give you the same result. Use whatever feels most logical or comfortable to you. Next future value scenario. The same $1,000 invested for 4 years, the same return of 20% per year, but with simple interest or simple returns rather than compound interest. The annual return equals the amount of the investment in cell B9 times the return in cell B12. We lock the column references by putting dollar signs in front of B9 and B12. Then we copy this formula over into D10, E10 and F10. Now the future value equals the amount of the original investment plus the sum of the annual interest amounts, which is $1,800 in total. Let me display the formula using formula text. Let's hide that simple return scenario and go to another future value scenario based on compounding with varying returns per year. 20% in year 1, 21% in year 2, 22% in year 3, 23% in year 4. The first way to calculate future value is similar to what we used before. Construct a formula and calculate the future value year by year. C16 equals B16 times, open parentheses, 1 plus C17, close parentheses. We do not lock the cell references with a dollar sign here. Copy the formula across to year 2, 3, and 4. The future value in year 4 of $2,179 is obviously higher than $2,074 of the earlier example, as the rate of return in most of the years is higher. There is a second way of getting to the same future value by using the Excel function FVSchedule. Let's go to Insert Function, search for a function by typing future value, and then FVSchedule shows up as an option. The description for FVSchedule is returns the future value of an initial principal after applying a series of compound interest rates. Exactly what we need. The principal is found in cell B16 and the schedule of interest rates in cells C17 through F17. Let me display the formula using formula text. As you see, this gives the same future value outcome of $2,179. Let's go to a future value scenario with multiple amounts. We invest $1,000 each year at 20% compound returns and want to know what the total future value is of the sum of these amounts. In order to do this using our first method, we need to layer the investments. Treat each of the $1,000 investments as a separate line item and calculate its individual future value. In other words, investment 1, investment 2, investment 3, investment 4, and the sum of these is the value of the portfolio. In cell C22, we type equals B22 times, open parentheses, 1 plus $B, $27, close parentheses. With dollar signs in front of column B, as well as in front of row 27, we make this an absolute reference to cell B27. Both the column and the row are locked. We can now copy the formula for each of the cells of investments 1, 2, 3, and 4. Then we sum the future value of each of the line items to a total of $6,442. Now that's a long way of doing the future value calculation. Let's use the magic of the future value function to make that a lot easier. Insert function, FV, link the rate to cell B27. Number of periods is 4. The payment is a constant amount of $1,000 per year, which is in cell B22. We don't have any lump sum. And in the last row, type, we put a 1 as the payment is made at the beginning of the period. Click OK, and then put a minus in front of the formula. Let me display the formula using formula text so you can see what is going on here. Same outcome of $6,442, but much faster. There's a companion function to future value that helps you calculate the recurring payment needed to get to a future value of $6,442. Insert function, type future value, and you see the Excel PMT function showing up in the family of functions. PMT calculates the payment for a loan based on constant payments and a constant interest rate. Let's give it a go. The rate is in cell B27. The number of periods is 4. We leave present value empty. We link future value to cell F27. Type is 1 as payments are made at the beginning of the period. Click OK and put a minus in front of the formula. As expected, the recurring constant payment is $1,000. We can now play around with varying amounts of recurring investments. $1,200, $800, $1,000, or with different rates. 5%, 10%, 15%, 20%. So why do I like to use this method of the layered investments? Well, it comes in very handy if you have multiple amounts of different value in this next scenario. $1,000, $1,500, $2,000 and $2,500. My layered method can handle that very easily. The same way it could handle a constant amount of investment of $1,000 per year. Same structure, same formulas. But how would you use the future value function in this case? Very simple, by layering it as well. Insert function, FV. Rate, $B, $37, number of periods 4, payment blank, PV or lump sum B32. Press OK and put a minus in front of the formula. Now let me display the formula using formula text, and let's copy over the formula into the cells below. Now we are going to adjust the second row to 3 periods and a lump sum in C33. To me, that is not an inconsistent Excel formula. In the third row, we need 2 periods, and we reference the lump sum in D34. And in the fourth row, 1 period and the lump sum in E35. Now sum these amounts and you get to the same future value outcome of $10,546. I hope this was a useful introduction to calculating future value in Excel. If you are interested in the Excel template for the various calculations, then join as a channel member and I will share the download link with you.